We all know the destructive power of fire in British Columbia forests. But how many of us are aware of the destructive power of this little insect? The mountain pine beetle. In British Columbia, we have large stretches of lodgepole pine which are now over 80 years old and therefore are very susceptible to beetle attacks. In the past, natural fires would have destroyed these stands. But man has controlled wildfire to such an extent that much larger quantities of pine are available than nature ever intended. So, beetle activity has increased. Like all bark beetles, the mountain pine beetle not only can kill a tree, but usually does. Current beetle attacks are destroying about 37,500 cunits each year. If harvested the same season as the attack, before checking has occurred, much of this timber can be used. Beetle attacks drastically upset logging plans because the large amounts of timber have to be cut fast, and road construction plans have to be changed. This beetle is found in most areas of the province, and the greatest damage is occurring in the south-central and eastern interiors and the Klina Valley. No outbreaks have been recorded in the Queen Charlotte Islands or areas north of a line drawn from Stewart to Hudson's Hope, 56 degrees north latitude. Major beetle flights occur in July and August, and infestations occur in mature stands 80 years and older, in green trees with an average diameter of over 20 centimeters. The following spring, the attack becomes visible as the tree's needles turn from green to yellow, then yellow-brown, and finally red-brown. The following year, needles will usually drop off, leaving the tree crown bare. These show as gray tops from a distance. The first effects of an attack can be seen from the ground as an outbreak begins as a small group of infested trees showing boring dust. Detection at this stage is possible only from ground surveys. If not stopped at this incipient stage, the small group grows into an infestation that can spread rapidly when the beetles fly to other host trees during the following July or August. Female beetles attack first in midsummer, soon followed by the males. They establish J-shaped egg galleries which can reach up to 60 centimeters long. These galleries score the inner bark and the sapwood surface. During gallery establishment, chemical attractants are released by the female, attracting beetles of both sexes to colonize the tree. The gallery entrance is plugged with boring dust, and the female starts laying eggs along the side of the gallery. These hatch about 2 weeks later into larvae, which mine horizontally from the galleries in the inner bark. The broods normally overwinter as larvae, completing their development the following spring. They then pupate in an oval chamber. Blue stain fungi surrounds the pupae in the chamber and will be used by the young adults as food when they change into beetles. Upon entrance, the mountain pine beetles carry blue stain fungi spores into the tree. This fungus can penetrate the inner bark and sapwood and kill the living cells of the tree by preventing normal flow of nutrients. Although blue stain fungi can kill the tree and adversely affect sales of affected lumber, it's the extensive checking that can also occur that lowers the merchantable value of the tree. There is a positive side to blue stain fungus. It is easily and more thoroughly penetrated by preservatives and makes good railway ties. Concrete poured into stained wood cures more rapidly. The mountain pine beetle and its associated fungus need only a few months to kill a tree. About mid-July, the new mature beetles bore through the bark to the outside in search of other trees to attack. As the trees remain green, not until a year later can attacks be detected from the air in June and July as the crowns are changing color. Ground surveys follow. Boring dust and pitch exuding from beetle entry holes are clear evidence of beetle attack. The presence of adults and J-shaped egg galleries confirm mountain pine beetle. Another confirmation is the presence of woodpeckers in search of the insects, and the bark flakes left by them are easy to see. The only viable approach to mountain pine beetle management in these large expanses of mature, over-mature lodgepole pine is to log in the newly infested areas. To do this, we need to change long-term logging plans, sometimes clear-cutting up to 800 hectares. This drastic measure may be preferable to leaving a stand of dead trees from which beetles fly to infest other pine. In a mixed stand, other tree species need not be logged, because the mountain pine beetle seeks out only pine. But if we left the pine, in 18 months they will have lost their value as a source of lumber, and are then only of marginal use for chips, a low-value product. The three highest hazard areas in red, brown, and yellow cover at least half of British Columbia. These are the best pine-growing areas and consequently the most susceptible to mountain pine beetle infestation. In a preventative maintenance program, it is necessary to harvest these high-risk older stands because as the trees increase in diameter from 20 centimeters, the percentage of infestation rises rapidly. If there is more than one tree with a diameter of over 20 centimeters infested per 1/2 hectare, the area should be logged by clear cutting to include all green infested lodgepole pine. It is best to remove harvested trees from the woods before the beetles fly in early July. In an area under attack, top priority should be given to harvesting green-infested trees and large-diameter uninfested trees while their value is still high. If we harvest only dead attack trees, we are simply following the beetle around. When wood recovery is not feasible, small groups of infested trees can be felled and burned. This is easily done in winter and early spring while snow is on the ground. Alternately, mountain pine beetle infestation can be treated by standing tree burning. A mixture of diesel and gasoline is sprayed on the infested stem and ignited. The aim here is to scorch the bark deeply enough to kill the brood with heat. Weather and climate also have their effects on the beetle. A very sudden and severe cold spell in autumn can reduce its numbers. In hot, dry climates with mild winters, the beetle thrives. Kamloops District and the Fernie area meet these conditions, and here insect damage is extensive. Sound long-term management programs can help reduce potential losses from the mountain pine beetle. In a high-hazard area with a history of beetle infestation, it is best planted or converted to another tree type. If another crop of pine is grown, it should be harvested before reaching the most susceptible age of 80 to 100 years old. It is also possible to develop mixed stands. Beetle outbreaks occur less frequently and wood production may be higher. Mixed stands offer good cover for wildlife and meet demanding watershed requirements. Future losses can also be reduced by cutting a series of small blocks in a stand. In so doing, a pattern of different age classes is created. In allowing an infestation to follow its natural course, the dead trees remain standing and become an extreme fire hazard. In Kootenai National Park, only an estimated 10% of the infested trees had fallen 14 years after being killed by beetles. Repeated beetle attacks can eliminate all the merchantable lodgepole pine in a stand. Once the area is cleared, another crop of pine will then start growing. The cycle begins again. The mountain pine beetle, omnipresent, as destructive as fire, a small but mighty menace to our forests.